Hello vlogs, I am Monisha G, Department of Pharmaceutics, working as the Assistant Professor in Wales University. So today you're going to see about pre-formulation studies. It is a part of science that deals with the formulation in pharmaceutical company for successful drug and its formulation or a promising dosage form. The content of the pre-formulation studies includes objectives, preliminary studies, bulk characterization, solubility analysis, stability analysis, and some chemical parameters as well. Introduction. Coming to the pre-formulation, it can be defined as a phase formulation development process where formulation chemist analyzes and characterizes various properties of new drug substance in order to figure out a stable, safe, and effective dosage form for the better management of diseased condition. Let's come for objectives. The prior investigation before formulation helps to give an idea that major and significant challenges associated with a potent compound of interest to be developed in commercial products and can be analyzed and removed. Further information of formulation chemists can use these information to design and develop a more stable dosage form. The main objective is to generate information that are very useful for the formulation development and more stable and also bioavailable dosage form that can be produced in masses. Why pre-formulation studies are so important? It is very important because it describes the process that optimizes the delivery of the drug along with the determination of physical and chemical property of the new drug molecule which involved in the development of stable and safe dosage form. And also, pre-formulation studies on a new drug molecule provide a very useful information for subsequent formulation of a physiochemically stable and biopharmaceutically suitable dosage form. Coming to the classification of pre-formulation, it is majorly classified into two types. One is physical property and another one is chemical property. In physical property, we are going to see about the physical form, which explains about the crystalline and amorphous state of the drug molecule, particle size, shape, flow property, solubility profile, and polymorphism. In chemical properties, we are going to see about hydrolysis, oxidation, reduction, racemization, and finally polymerization. Coming to the physical property, the bulk property of the new drug molecule are classified according to the crystallinity, polymorphism, particle size, flow property of the powder, and surface characteristics which involved in the drug development. In that, we are going to see about the crystallinity. What is meant by crystallinity? Every new drug molecule have different type of structure of crystals according to the growing environment. It may be cubical, fibrous, angular, prismatic, spherical, granular, or plate. You can see in that picture. Characterization of crystallinity involves the following method. First and foremost is microscopy. Secondly, DSC, that is your differential scanning colorimetry. Then your infrared spectroscopy, thermogravimetric analysis, and finally X-ray diffraction. In this technique, the substance are examined under the microscope. It gives information about the shape, thickness, and particle size of the drug molecule. And here we can study about the crystalline morphology and difference between the polymorphic character of the molecule. Next one in the list is differential scanning colorimetry. In this picture, you can see the device. In DSC, the sample and the reference material are subjected to the linear heating process where temperature is raised, but the temperature of the two materials should be the same and the graph is plotted. In DSC, the differential thermal analysis, heat is lost and gained, resulting to form physical or chemical transitions that occurs in the sample. The enthalpy changes are occurred which may be exothermic as well as endothermic caused by the phase transitions. This is how the graph has been plotted with the values of the DSC, and there is a occurrence of endothermic reaction which you can see with the values of the graph. Coming to the infrared spectroscopy, here the study of interaction between the electromagnetic radiation along with the vibrational and rotational resonance. This is termed as IR spectroscopy. It has the ability to differentiate isomer groups such as cis and trans. It also gives information regarding the functional group present in the new drug molecule. FTIR use both qualitative and quantitative analysis of the sample. It is an excellent analytical procedure performed to determine the content of moisture. TGPA helps to determine the temperature at which material loses the weight due to evaporation or decomposition. The weight loss begins at 63 degrees Celsius and continues at 137 degrees Celsius and at 163, resulting in the thermal decomposition. It also determines the temperature at which loss of weight takes place and indicates the stability of the compound. Coming to the X-ray diffraction. When a beam of light of non-homogeneous X-ray is allowed to pass through the sample, the X-ray beam is diffracted and it has been recorded by means of photographic plates. So in that picture, X-rays are allowed to pass through the sample and the values has been detected with the help of the detector. It is used to differentiate the amorphous and crystalline form, and this method is very tedious method and time consuming, hence unsuitable for routine uses. Polymorphism is defined as the ability of a compound that can be exist in one or more forms, and it also defined as the compound to crystallize as more than one distinct crystalline species with different internal structure. The different polymorphs depend on solvents, temperature, pressure, rate of cooling. The different polymers vary in physical properties such as dissolution, solid state, stability, compatibility. You can see the picture of the polymorph in the other side. Hygroscopicity. It is the tendency of the solid to take up the moisture from the atmosphere as it is subjected to a controlled RH program under isothermal condition. The deliquescent molecule absorbs moisture from the atmosphere easily. The change in the moisture level can greatly influence many parameters such as chemical stability, flow property, compatibility. The used for the characterization is thermal gravimetry analysis, Karl-Fischer titration, and gas chromatography. Flow properties of powder can be influenced by the changes in particle size, shape, and density, as well as electrostatic charges and absorbed moisture. The flow property depends on the frictional force and force of cohesion between one powder particle and another. The flow properties of the powder will determine the nature and quantity of the excipients needed to prepare a compressed or powder drug dosage form. This refers mainly to factors such as ability to process the powder through machines, the analytical methodology used for the characterization. The free-flowing powders may be characterized by simple flow and the rate of apparatus consisting of grounded metal tube from which drug flows from one orifice to another. Another method used is compressibility. The powder molecules may exist in different shape according to the nature. The next one is fine particle characterization. It is the study of the particle which gives an information about the solubility, dissolution rate, absorption, etc. Particle size and surface area of a solid drug are inversely related to each other. The analytical methodologies used for the characterization of fine particles is light microscope, sieve analysis, image analysis, BET nitrogen absorption, scaling, electron microscopy. Coming to the next topic, drug pKa ionization constant. It is the dissociation constant of the drug where percentage of ionization can be calculated. The ionized substance exists in the form of lipid which is insoluble, therefore permeation is low. The unionized substance is lipid soluble, thus dissolved in the lipid material of the membrane and transported by passive diffusion. For acid compounds, a formula has been given where pH equal to pKa plus log of unionized drug divided by ionized drug. For basic compounds, a formula is given where pH is equal to pKa plus log of ionized drug divided by unionized drug. The degree of ionization depends on the pH of acidic drugs and pKa ranges from 3 to 7.5. For basic drugs, pKa ranges from 7 to 11. Analytical methodologies used here are potentiometric titration and UV and visible spectrometry. In this picture, you can see UV and visible spectrometry, which are performed with electronic transition depends on the electron. UV study of a compound gives information regarding unsaturation compounds. Partition coefficient. It is given by the formula CO divided by Cw, where CO is the organic phase and Cw is the aqueous phase. In separating funnel, two different solvents are taken, which is X and Y, which is shaken vigorously and rested for few minutes. After few minutes, the organic solvent separates from the aqueous solvents, and this scenario is stated as partition coefficient, which is given by the law. A given substance at given temperature will partition itself between two immiscible solvents in a constant ratio of concentration. Partition coefficient is a ratio of equilibrium concentration of a drug in oil phase to equilibrium concentration of a drug in aqueous phase. The last one on the physical property is dissolution studies. It is performed to know the gastrointestinal absorption and other physiochemical properties. The definition of dissolution study is given by: it is a process in which solid substance solubilizes in a given solvent, that is, a mass transfer from a solid surface to the liquid phase. The analytical methodology used for characterization is chromatography, and in pre-formulation studies, chromatographic techniques such as TLC, HPLC, GC plays a major role. Analytical data from TLC may be required to precise determine the kinetics of decomposition. Chemical properties. In chemical property, the first and foremost property is oxidation. It is a common pathway for drug degradation in which both solid and liquid formulation. Oxidation process is nothing but the gain of oxygen molecule and the loss of hydrogen electron. Oxygen occurs in two ways. One is auto-oxidation, another one is free radical oxidation. A common example of oxidation in our daily life is color change in the apple when it is exposed to the open air. Factors that affect oxidation process are oxygen concentration, light, heavy metal, particularly those have two or more valence states, hydrogen, hydroxyl ion, and temperature. The oxygen can be prevented by the following steps: reducing the oxidation content, storage in dark and cool condition, addition of chelating agents such as EDTA, citric acid, tartaric acid, adjusting the pH, changing the solvent such as aldehydes, ether, ketone may influence free radical reaction, and finally an addition of antioxidant or reducing agent, example hydrogen, carbon dioxide and zinc. List is hydrolysis. It is the cleavage of a chemical bond by addition of water. The reaction of water with another chemical compound to form two or more products involving the ionization process of water molecule by splitting the other compound. Prevention of hydrolysis includes pH adjustment, addition of water, miscible solvent in the formulation, formulate the drug solution close to its pH, and optimum buffer concentration. Addition of surfactants, ionic, non-ionic, anionic, and addition of salts, esters. The process in which one enantiomer of a compound such as L-amino acid converts into another enantiomer. Racemization is a conversion by heat or by chemical reaction of an optically active compound into an optically inactive form. It is a mirror image referred as racemic mixture. The compound alternates between each form by the ratio between the plus and minus groups approaches 1:1, at which the point it becomes optically inactive. The interconversion of isomer to another can lead to toxicological effect as well as different pharmacological effect and different pharmacokinetic properties such as absorption, distribution, metabolism, and elimination. To the biological significance, many psychotropic drugs show different activity of efficiency between isomers. Another example is methadone, of which one isomer has optical activity as an opioid antagonist, another one is NMDA antagonist. Last one on the list is polymerization. Polymerization is the process of reacting monomer molecules together in a chemical reaction to form a polymer chain, which is three-dimensional network. It is a continuous reaction. More than one monomer reacts to form a polymer. Example, shellac is an agent undergoes polymerization, hence prolonged disintegration time and dissolution time. BCS classification. It is defined as or explained as biopharmaceutical classification system was developed in the year 1995 by a group of scientists, Amido and his team. Biopharmaceutical classification can be defined as a scientific model for categorizing the active drug molecule to different categories or classes based on the aqueous solubility and permeability. The applications of pre-formulation biopharmaceutical classification system of drugs and its significance. It was developed in the year 1995 by the group of scientists Amidon and his team. BCS system can be defined as a scientific model for categorizing the active principle of drug molecule to different category or classes based on alpha solubility and intestinal permeability. Application of BCS classification helps to predict in vivo functioning of the drug based on solubility and permeability, also assist various stages of drug discovery significance. It acts as a predictive tool for bioequivalence study and design through accurate in vivo study. It also aids in vitro in vivo correlation study. This is the model of BCS classification. It has four classes: class 1, class 2, class 3, and class 4. Class 1, example propranolol, verapamil, metoprolol. Class 2, ketoprofen, naproxen, carbamazepine. Class 3, ranitidine, cimetidine, atenolol, vancomycin. And Class 4, furosemide, hydrochlorothiazide. In BCS classification system, class 1 has high solubility, high permeability, class 2 has low solubility, high permeability, and class 3 has high solubility and low permeability. Class 4 has low solubility and low permeability. Objectives of BCS class boundaries. Rapid dissolution ensures that in vivo dissolution is not likely to be rate-determining step. Solubility. High solubility ensures that the solubility is not likely to remove dissolution and therefore absorption takes place. And permeability. High permeability ensures that drug is completely absorbed during the limited transit time through small intestine. And hope you understand the P formulation of the drug molecule along with the physical properties, chemical properties, and the BCS classification. Thank you so much for listening to my video and spending your most precious time. See you in the next video.